Good evening, folks. This is Ron Tyler with the Emergency Management Associates.
This is Ron Tyler with the Emergency Management Associates coming to you live from the Crossroads of the West in Lake City, Utah. The time right now is 7:05 p.m.
Barely clear on the backside of the sun, and then the earth is sun hitting the earth is located around 3.5 miles southeast of the earth now. The solar wind is also
Good morning, good afternoon, good evening, ladies and gentlemen, and everybody else is joining us. Welcome to Emergency Management Associates, coming to you from the Area Command, 392 miles west of Kitty Hawk Beach, North Carolina. As we have been doing for quite some time, we're going to start off this evening's program with a salute to the country, the national anthem preceded by the Pledge of Allegiance. Would everybody please rise?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now would you make welcome straight from Washington, D.C., the United States Army Corps Quartet.
Yeah.
Oh, say can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the
America's finest, the United States Army Barbershop Quartet, coming to us from the Barbershop Quartet Convention in 2015. These wonderful men have given us this opportunity to show them and show their finest every day for quite some time now, and we appreciate it. We want to honor all of our men and women throughout the world, wherever they might be. Army, Air Force, Marine Corps, Navy, Coast Guard, Space Force, whatever. We appreciate and love each and every one of them. That is our finest that we have. We want to thank them for their service. We also want to thank those men and women of our allied armed forces as well. We thank you for your service, and thank you for letting us thank you. God bless you all, and may you all return home safely after your tours of duty end. God bless you, and thank you so much. We really appreciate it. Folks, we have a lot to talk about. First thing I want to talk about is some things that we picked up in our mail today. We have some things that we picked up. We got 2 cards with some donations. This first card comes from a wonderful family in Canada. I want to thank them so much for what they've done for us. It means so much to us. They sent us a beautiful card as well. Let me show you the front of the card. Okay? It's truly wonderful. Okay? Just a beautiful card here. God is always with you. Thank you for your commitment to protecting others with expert information on a consistent basis during your difficult and trying times. May it give you strength just knowing how much God loves you and that He's there for you and with you night and day, thinking warm thoughts of you. We really appreciate that. You guys in Canada make our day, each and every one of you. We love and appreciate you. We appreciate all of you all over the world that support and watch this channel. Now, another wonderful lady, Miss Brown from Lenore, North Carolina, which is just about 30 to 40 minutes away, sent us this beautiful card. And this is actually a place here in North Carolina with beautiful angelic falls, waterfalls. And I love waterfalls, guys. Since God is everywhere, is what this states. It's a beautiful card. May you feel that He is as close to you as a gentle hug. Many blessings and much love to you, Ron. I appreciate the time you put into gathering information and presenting it to us. Thank you so much, Lori. Lori, we really appreciate it. But Lori went even a step further. She sent us another prize gem that I want to share with you. This is a piece of tourmaline. Okay, this is a piece of tourmaline, guys. It's gorgeous. It's snowflake, similar to snowflake obsidian. Okay, I just absolutely love this. Okay, it's absolutely gorgeous. It's perfectly round. It also comes with a stand that I'm going to set up here in my office on top of my radio, which is across from my desk here, so I can look at it every day. It's beautiful. It's stunning. And I do appreciate it, guys. I do appreciate it. It means a lot to me. I'm going to add it to my rather large rock collection that I have too. You guys have made it possible, together with Sandy from San Francisco, that has sent us many rocks and gems over the past few years. This is a black tourmaline pennant. A black tourmaline pennant. And we greatly appreciate it, guys. It's just beautiful. Just beautiful. And that comes from a volcano. That is just one of the things that comes from a volcano. It's gorgeous. Folks, we have some things I want to discuss with you. And one of the things that I want to show you is that we are still getting earthquakes over at Lake Alamanor. Okay? Remember that 5.6 that hit there just a few weeks back? And it keeps hitting. A 5.6 and a 5.2 after that. According to Terry Rempel, and I talked about this a few days ago, according to Terry Rempel, those were the two earthquakes that we were looking for, within 8 hours of each other. This is in the southeastern part of this Cascadia mountain ridge, the Cascade mountain range. Okay, this is just southeast of Mount Lassen, just barely southeast of Mount Lassen. And as you can see by this one earthquake that you see here in brown, the brownish orange, that is a 2.5 earthquake that hit today, a minor earthquake that hit today. By these other yellow circles here, these yellow circles typify what has been happening during the past few days to several weeks. Okay, the earthquakes keep hitting here. There's been about 500 earthquakes since the original onslaught of the 5.6 and the 5.2 earthquake that is hit here. Okay, it's unreal. It's continuing. Now, I want to show you something else. Speaking of Mount Lassen, look what has happened at Mount Lassen today. Okay, it started off up here at midnight. Excuse me. This is actually, oh my gosh, this happened on Wednesday. Starts off here at 2 p.m. on Wednesday. Look at everything that's happened. Okay? It shows magma. Each and every horizontal line here shows magma coming into the magma chamber. It's thinner and gets thicker and thinner and gets thicker and thicker and gets thinner. Those are called magma pulse signals. Magma pulse signals. Okay? That's typically what we see when we have magma infill coming into the volcano. Look here. Okay? I'm going to scroll up here to let you see this, and I'm going to enlarge it. Okay, look what we have here. Okay? Look what we have here. Okay, this is today. This happened today. Okay? Look at these earthquakes here. And it's just not the earthquakes hitting Mount Lassen. There are steam signals as well. Little lines, little vertical lines with curlicues on them. Vertical lines with curlicues on them. Yes, we have some earthquakes as well. Okay? But look at this. Over and over and over again. This has continued all day long. Literally all day long. And look at this down here. This is after 1:30 this afternoon. Heavy duty magma coming into the magma chamber and earthquakes. Back to back to back earthquakes. Some larger than others. Some 2.0, 2.5. Others look like, over here on the left, look like they're at least a 3.0 earthquake. And we can see the 3.0 earthquakes all over this seismogram. Okay? You can see the 2.0s as well. All over the place, guys. Okay? So Mount Lassen is very busy. Mount Lassen's always busy. So is Mount Shasta here in Northern California. We can also say that the entire Cascade mountain range, as we've seen it earlier this week, I showed it to you, seismogram by seismogram, the entire range is busy, every one of them. Now, why am I emphasizing this? I'm going to take a little break and let you think about that. Okay? think about why the Cascade Mountain Range is so busy. Okay? First off, I want to talk about Tonga and south of Fiji. Yesterday we had a 7.2 magnitude earthquake that hit over in the South Pacific. Over in the South Pacific, guys. Okay? What do you think we have here? What do you think we have here? This helioplot, guys, shows us the extended range of the shaking of the earthquake. Look up here at the top, okay? At the top on the left-hand side, this was 10 p.m. last night Eastern Time. The earthquake hit late in the afternoon yesterday. Now, I have counted the number of lines between when it hit yesterday until now. Okay? They number 16 hours. It numbers 16 hours. 16 hours of shaking. 16 consistent hours of shaking. That means that this earthquake was indeed at least a 7.2. As I showed you yesterday, I was very disappointed with the helioplots, because as I explained it to you, the helioplots did not do the earthquake justice. It didn't seem like this earthquake was only a 7.2. Okay? It was rated as a 7.4 at one point in time. It was reduced to 7.2. It started out as a 7.0 and increased to 7.2 to 7.4 and then reduced to a 7.2 again. But that's not what the helioplots showed yesterday. They possibly showed a 6.5 to 6.7, 6.8. But right here is evidence that this was a much larger earthquake. This was indeed at least a 7.2 earthquake, regardless of what the other helioplots showed with the vertical magnitude lines. The vertical magnitude lines. So this was at least a 6.2 earthquake. Now, on top of that, we've had more earthquakes today. Let's go back and take a look, not go back, but let's go down over here and take a look at the USGS map. I told you that I don't even like to use this, but this at least gives us a good idea of where we're at. Okay? Let's leave the United States for a minute. Let's go over here to the South Pacific. After last night's 7.2 earthquake, we've had numerous aftershocks. The first aftershock right here was a 6.0. A 6.0. Now this happened at 4:11 this morning. 04:11 this morning Eastern Time. Okay? This one here is a 6.2. A 6.2. Folks, this is a 200% increase. A 200% increase from the 6.0. Okay, this is an increase in power, and this was an aftershock. The other earthquakes here, quite honestly, this is a 5.0. Right next to this 6.2 is a 5.7, very large earthquake. These other earthquakes are 4.7 and 4.8 magnitude quakes. Okay? So we had a 6.0, a subsequent 6.2, a 5.0, and this 5.7 and other moderate quakes. They were not felt. These quakes were not felt because they were far from land. But look where these quakes were. These quakes are on the earthquake fault south of Tonga and south of Fiji. South of Tonga and south of Fiji. Up here to the northwest. This is Fiji region. This is a 4.5 magnitude quake. This also is a very deep earthquake. 336 miles deep. Way down deep in the earth. Way down deep in the earth. And this 4.8, you have to look at this. This 4.8 is going to propagate, for lack of a better word, it's going to result in at least a 5.5 to a 5.7 earthquake as a result of this 4.8. And that larger, shallower quake is going to hit either east, west, north, or south of where this quake hit. So we're going to see a substantial increase in magnitude here. These other quakes here are fairly shallow. Even this 6.2, this is only 18 miles deep. This 6.0 here, I'm sorry, that was a 5.0. Let me increase this a bit and bring up the other one here. This 6.0 here was 13.7 miles deep. These are shallower quakes. But that 4.8 here is going to result in at least a 5.5 to a 5.7 earthquake. That's going to happen probably within the next 72 hours. Or at least within the next 5 to 10 days. Usually 72 hours later. That's a big deal. Now, they're not showing any more quakes and tremors here. They're wrong. There are quakes and tremors here. They're not showing anything over here in the Kermadec Islands or New Zealand. That's a joke too. There are plenty of small and minor earthquakes all over this area that they're not telling us about. Look over here into Papua New Guinea. This is a 4.9, 5.0 quake. Again, the 0.9 society. So I upped it to at least a 5.0. This is also a shallow quake. This is 22 miles deep. Just to the west of this, this is also in Papua New Guinea. It's a 4.5 quake, 110 miles deep. How is that possible to go from this quake being 52 miles deep to this one being 118 miles deep? And then only showing two other earthquakes over here in Indonesia, when there's another 18 earthquakes here. Really? This is a 4.5 in the Valdese Sea. This is also 103 miles deep. Right next to it is another moderate earthquake of 4.5 in Malmö, Indonesia. This is 128 miles deep. And again, there's a bunch of other earthquakes here that they're not telling us about. One of the other large earthquakes over here is in northeast India, Bangladesh border area. This is a large 5.0 earthquake. This is 6.2 miles deep, 10 kilometers deep. Crazy. Almost insane. Another 4.8 earthquake, moderate earthquake, 25 miles deep. 4.8 over here in northern northern Philippines, north of Luzon Island, Philippines. Going up here, okay, this is in the Bonin Islands region of Japan. It's a 4.1. Again, look at where it's located, right on top of the fault here. There's 7 different faults here, 7 different plates, all subducting one under the other here in the South Pacific, the Southwestern Pacific. Okay, going up to Japan, there's 2 earthquakes that I want to tell you about. This one here is a moderate 4.4. This is a low range 4.4 moderate earthquake over here in Sakura, Japan. Now, I want to show you something. I'm zooming into this to show you what I'm talking about. USGS has this 2 miles west of Sakura, Japan. If that's the case, Sakura, Japan is right here. This is allegedly 2 miles west of there. Why did they not put it here where it's closer to this city? Inquiring minds want to know. Again, as I pointed out in the past, USGS does not want us to know exactly where these quakes hit. They're erroneous in their locations. Yes, a 4.4 earthquake did hit, but where was it closest to? Okay? Over here, this is also off the east coast of Honshu, Japan. This was another 4.9 earthquake. 0.9 society is alive and well. This was a 4.9 5.0 large quake. This was 27.5 miles deep. In the crust. The crust of the earth that we walk on is anywhere from 39 miles to 69 miles deep. So this is in the crust of the earth. Okay? That's Japan. Okay? Nothing else here. But when we get up here to Russia, okay, the Kamchatka Peninsula, here we have another 4.9, 5.0 magnitude earthquake. This is right next to the Aleutian Island Fault. Right on the juncture of this other earthquake fault hooking up with the Aleutian Island Fault. So this same 5.0 earthquake is going to travel the Aleutian Island Fault now. This is 27.5 miles deep. Okay? We have some minor goings on in the Rad Islands here. This is the largest of the earthquakes in the Rad Islands. This is a 1.3 tremor. The others are microquakes. As we hook to the east, this is also a 2.3 earthquake. This is 6 miles west-northwest of Atka, Alaska. Atka, Alaska. We go further east. This is in the Fox Islands. This is a 3.5 small earthquake here. 151 miles deep. This is down in the asthenosphere. This is where the plastic magma is, in the asthenosphere. Then we have 2 other microquakes here. We go further east through the Aleutian Island chain up here. This is a 4.6 moderate earthquake here. Okay? You might say this is in the Gulf of Alaska, couldn't we? It's just south of the peninsula of Alaska. Now this is a very shallow quake, 5.9 miles deep. Okay? Then we go over into the peninsula. This is a 2.4. This is 57 miles deep. Okay? This could be down in the asthenosphere as well. Okay? Then we go further northeast here, up in the upper peninsula here. This is Karluk, Alaska. 1.0 tremor. Okay? Further northeast, Igugig, Alaska, a 1.8. This here, guys, these earthquakes are all related. Okay? Why do I say that? What do you see here? This is a volcano, isn't it? This is old Ililama volcano here. Look at these series of tremors right here. This is old Ililama volcano. It has been stirring. It has been throwing out gas, steam. Old Ililama volcano has not erupted for a very, very long time. Could it erupt? Yes, it could. With all these tremors and earthquakes we've been seeing here, this could erupt. Okay? Then we go further north. Okay? This is old, not old, I shouldn't say old. This is Mount Redoubt. This is a 2.1 earthquake at Mount Redoubt. Mount Redoubt has not only put up steam, it's also erupted too in the recent past, within the last year. Within the last year. Could it erupt again? You bet it can. And it's still putting up steam. Okay? Then we go up here into southern Alaska here. Look at all these tremors here. This is a 1.4 near Houston, Alaska. Over here, still in the... Oh. Sorry guys, my medication's causing me to sweat like gangbusters here. This here is still in the water here. Okay? This is the Cook Inlet. Just north of here is Anchorage, Alaska. This is a 1.2 tremor. North of here, Houston, Alaska, another 1.4. Northwest of there, a 1.8, Willow, Alaska. This is a 1.4 in Fishhook. 1.4, 1.4, 1.4, and 1.4, huh? Oh yeah. We go almost directly west. This is Skwentna, 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 Alaska. This is a 1.7. It just happened. We go over into Southern Denali National Park here. This is a 1.8. 1.8. Northern Denali, Alaska. This is a 1.5. Again, USGS cannot give us the exact location where this tremor happened. They say it's 25 miles south-southeast of Denali. No, it's not. It's on the northwestern edge of Denali, not south-southeast. See, they still can't get the directions right. Northwest of there, this is 4 miles south of Denali. No, it's not. It's north of Denali, 1.6, right next to 1.7. It's incredible, guys. They can't get their acts together. Northeast of there, 1.9. This is a 1.8. These are all tremors. Then we go up here to the biggest earthquake up here to the north. This is Minto, Alaska. This is a 2.6 earthquake. a 2.6 earthquake. This is central Alaska. We go over here to the west to what I call the palm or hand of Alaska here. That's what it looks like. This is a 3.3 magnitude earthquake here. 3.3 magnitude earthquake. We are continually seeing bigger earthquakes here. Not large, but bigger than what we've seen before. Before it was just tremors. Again, the seismicity is increasing. Right here is Teller, Alaska with a 3.1. Okay? So we're getting threes over here in the hand of Alaska to the west. Over in the Baltic Sea to the north of here, we've seen a 5.0 just this past week. Okay? So we're consistently seeing more and more earthquakes up here. Okay? Now, I want to shoot quickly before I go anywhere else back to the U.S. Okay, look over here. This is wild. Okay? We're showing two earthquakes here. Over here in the Middle East. Okay? This is north and east of where we've had all the big earthquakes and continuing aftershocks. This is a 4.2 over here in northeastern Turkey. But what they're not showing is the other 100 earthquakes here in the Turkey-Syria region. We're still getting 100 plus earthquakes every day as a result of the 9.0, 10.0 earthquake we had here a few months ago. Okay? They're still not being honest with us. There's 20-some earthquakes over here in Greece that they're not telling us about. 20 plus earthquakes over here in Italy and Sicily that they're not telling us about. More earthquakes over here in the Alps. Those are just tremors. Over here, this is Western France. This is a 4.8 magnitude earthquake. A moderate earthquake over here in Western France. We have not seen a moderate earthquake here in a very, very, very long time. This is Kircon, France, a 4.8. This is only 3.1 miles deep. It's in the crust here. It's in the crust. Now, look where the Craton edge here in the Alps is. The Craton edge. The Craton edge continues southwest over here into southwestern Spain. Up here we have a 4.8. Something else is going on here. Something else is going on. Because the Craton continues down here and borders France and Spain here. And yes, we have more tremors here. And we have more tremors here in Spain. And over here near the eastern side of the Strait of Gibraltar that they're not talking about. Crazy. This is insanity. More earthquakes over here in Iceland that they're not telling us about. Okay? Now, they're showing two earthquakes over here in South America. This is a 4.7 at the Chilean-Argentine border. San Antonio de los Cobres, Argentina, the border of Chile and Argentina. This is also a moderate 4.7 earthquake. 112 miles deep. This is also down in the asthenosphere. This is a 4.4 down in Coquimbo, Chile. The same place where I believe it was 2010 where we had an 8.0 earthquake here. Coquimbo, Chile. Central America, and by the way, South America has had 20 plus earthquakes. They're showing us two. Why? Why only 2? Here in Central America, this is a 4.1. Puerto Cortes, Costa Rica. Puerto Cortes, Costa Rica. This is 6.2 miles deep, 10 kilometers deep. Southern Mexico the other day had a 5.0 earthquake. Okay? Oaxaca, Mexico. Today, over here in Santiago, I think they call it Xanica, Xanica, we had a 4.8 earthquake, 22 miles deep. Just north of there, this is another 4.2 in Oaxaca, Oaxaca, Veracruz border region. Oaxaca, Veracruz province border region. Okay? These are only 2 of about 25, 30 earthquakes here in southern Mexico. Again, they're not telling us about that either. They also don't want to tell us about an earthquake over near Acapulco. Just off the coast of Acapulco, right here. Another 4.5 earthquake here. And further north up here, just off the coast from Manzanillo and Puerto Vallarta. They don't want to tell us about much of anything. Okay? Then, before I go back to the United States, I want to talk about Puerto Rico here. Okay? We're still getting aftershocks of the 8.0 and 8.4 earthquake that I told you about the other day that hit here nearly 4 years ago. This is a 3.0 small earthquake here. West-southwest of Fuig, Puerto Rico. This is a 2.4 south of Indios, Puerto Rico. This is just off the coast of Guanica, Puerto Rico here. This is a 3.0. These are small earthquakes, ladies and gentlemen. Aftershocks of 2 very strong major earthquakes that were human caused. Human caused. And they're continuing to hit here 4 years later. This is a 2.2 over here in south central Puerto Rico. A 2.2 near Santa Isabel, Puerto Rico. This right here next to it to the east is a 2.4 near Salinas, Puerto Rico. Over here in the Mona Strait, okay, this is a 3.5. This is just east of the Dominican Republic here. A 3.5 that's 69 miles deep down in the asthenosphere with the magma. The magma's hitting great big huge rocks in the bottom of the crust, causing earthquakes. Yes, that's what we believe is down there, and that's why we're having earthquakes caused down in the asthenosphere. Flowing magma does that, fracturing the rocks, causing earthquakes. Over here, just northwest of Puerto Rico. This is near the same location where we had a 6.3 earthquake just 3 years ago. 3 years ago, the same night that Hurricane Maria hit the southern coast of Puerto Rico. 6.3 hit up here in northwestern area of Puerto Rico, out here in the Caribbean here. This is another 3.0 earthquake. To the northwest of there, we have a 2.8 here north of the Mona Passage that we told you about. This is an earthquake that came off of this earthquake fault here. Okay? The Cayman Island region. Okay? This is the Cayman Ridge. The Cayman Ridge. The Cayman Ridge earthquake fault starts over here in Guatemala. It continues west through the Caribbean here. Then it takes a turn to the north here and goes just south. It continues east just south of the Cayman Islands here. It goes north of Jamaica, skirting the coast of Cuba. It continues north of Haiti, north of the Dominican Republic, north of the Mona Passage, dropping these earthquakes here. A 3.4 here. This is north of Arecibo, Puerto Rico. Arecibo had, until just about a year or so ago, it had a radio telescope in Arecibo. An earthquake took that down. This same Cayman Ridge dropped a quake right here. This is a 3.8, 84 miles north of Suarez, Puerto Rico. It continues east here. Okay? We have an earthquake just north and northeast of Culebra, Puerto Rico. Culebra, Puerto Rico is an island out here off the coast of Puerto Rico itself. Culebra is a beautiful island, an absolutely stunning island. Most boaters go there to visit Culebra. There's a very few businesses there, and I only think a handful of people live near Culebra over here. But this earthquake is northwest of Culebra. This is another 3.4. And over here near the Cayman Ridge here is another 3.5. This is northwest of Charlotte Amalie, Virgin Islands, U.S. Virgin Islands. The Cayman Ridge continues east and then goes southeast and then south around the Leeward Islands here. It continues south and then takes an immediate turn to the west into northern Venezuela here. Northern Venezuela. So that's how we get earthquakes in this area from the Cayman Ridge. So now you understand that. Let's go over to the United States of America now. Okay? Over here. This is one of those earthquakes that are continuing to hit North Carolina. This is a 2.1 magnitude earthquake in Canton, North Carolina. Northwest of where I live, about 75 miles northwest of where I live here in Morganton, North Carolina. Over here, and this is directly in the center of the New Madrid Fault. This is Powhatan, Arkansas. This is another 2.0 earthquake. I will bet you that there are a bunch of 2.0s and 2.5 earthquakes here. The earthquake magnitudes are increasing in this area. I showed you that last night. Okay? The New Madrid Fault is active. It's getting more active by the day. We continue west. This is Reno, Oklahoma. We get more and more earthquakes happening here in Reno every day. This is also a 2.2 here. Southern Oklahoma. Western Texas. This is a 2.1. This is a 3.0. A small 3.0. Now, folks, we have these earthquakes here. They're not stopping. These are oil and gas earthquakes here. Oil and gas earthquakes. This is a 2.3. This is a 2.4. This is a 2.2. They're all over here. They're literally all over. Go northwest here. This is in Boulder Town, Utah. Bouldertown, Utah. Kimberly Hopkins just gave us a $10 super chat. Thank you so much for that, Kimberly. We really appreciate it. God bless you for that. We really love you guys. You guys are awesome supporting our program like this. It helps pay our bills here to keep this program going. By the way, our broadband internet is increasing in price again, and I'm looking for substitutes for it. Going to another company for internet here. It's going crazy. All prices going double. Okay? I just figured out last night, my grocery bill has doubled over last year. Just groceries. Just groceries. So that's in Bouldertown, Utah, a 2.2 earthquake. We go north. This is Kenilworth, Utah. Kenilworth, Utah. This is in central Utah. It's a 1.6 tremor. 1.2 miles deep. Okay? Kimberly Hopkins, you're awesome. We love you. We really love you. Going further north. This is just north of the Utah border in Wyoming. This is Star Valley Ranch, Wyoming. A 2.2 magnitude earthquake, minor earthquake. We continue north. This is Kelly, Wyoming. Northeast of Kelly. This is a 1.2 tremor. We continue northwest here at 0.6 in western Wyoming. This is over at Hebgen Estates. Okay? These are all just northwest of Yellowstone. Okay? You can see Yellowstone Lake right here. Okay? So this earthquake still in Wyoming, 0.6 here. We go over here. This is they say this is 9 miles east of Hebgen Lake Estates. Hebgen Lake is right here. Okay? But this isn't the only tremor here. Look at this, guys. This is a swarm of tremors just northeast of Hebgen Lake. Okay? That's a 0.4. This is a 1.4 here. This is a 0.4 microquake. This is a 0.8 microquake. This is a 0.5 microquake. This is a 0.6 microquake. There's a small swarm of tremors here, aren't there? Just northeast of Hebgen Lake. Can I remind you what happened in Hebgen Lake back in 1959? Back then we had a 7.1 major quake, and it may have even been larger because we did not have the Richter scale accurately in this area. This may have been as much as an 8. It knocked over fireplaces and unreinforced masonry. It destroyed schools and other buildings. It caused a cabin to slide into Hebgen Lake here. It took one of the highways here and slid it also into the lake here. Crazy. Almost insane. Right down here is the Hebgen Lake Estates. All these estate homes down here. All over this area. And this is an older photograph. There's probably a bunch more estate homes here. This is Hebgen Lake Estates here. Okay? Literally all over. It's a gorgeous area. I've been here. Okay? We have all those swarms of earthquakes there. Further east, Spencer, Idaho. This is on the western side of the Yellowstone magma chamber. The western side of the magma chamber. This is 9.4 miles deep, probably down in the magma chamber. The magma chamber is 11 Grand Canyons in size. 11 Grand Canyons in size. North of this, This is a 0.4 in Enos, Montana. Microquake in Enos, Montana. Just barely northeast of there, this is a 0.2 in Whitehall, Montana, a microquake. North of there we have a 1.1 minor tremor here in Radnorburg, Montana. Just north of there, this is a 0.8, they say is a quarry blast. 4 miles west of Townsend, Montana. Isn't that interesting? This time they have it right. This is a quarry here. I pointed out that USGS can't get things right. This one they finally got right. Only a handful of these do they get right. Most of those times they're tremors and microquakes, not quarry blasts. Okay? That's what's going on here. Further west here, this is Smith Ferry, Idaho. This is a 2.1 earthquake. Northwest of there, this is Haines, Oregon. Haines, Oregon, a 1.6 explosion. Okay? No, it's not an explosion. This is in the mountains here. This is in the mountains. Okay? This is a 2.6. This is an earthquake. Right next to this other one, which they say is a blast. Okay? They're not. Those are earthquakes side by side. Okay? First is 2.1 here, and this one here, a 2.6 in Smith Ferry, Idaho. They're not quarry blasts or explosions. Over here is Haines, Oregon. They say this is an explosion here. 4 miles northwest, northwest of Haines, Oregon. Okay? Now they did me another number here. So I'm going to do them a number. Hold on here, guys. I'm getting my map back. I got it. I got it. No matter what they do to me, I'm on top of it now. Woohoo! I've got him. I've got him. Anyway, guys, they say this is an explosion 4 miles northwest of Haines, Oregon. A 1.6 explosion. That's interesting. This is an agricultural area. Yeah, it could be an explosion, but I doubt it. This is over a half-mile deep. I'm sorry, no, it's not. This is just over a quarter-mile deep. 0.6 miles deep. Just over a quarter-mile deep. Okay? We don't usually get explosions over here in an agricultural area that deep. Sorry, USGS, you lose again. Okay? But that's what's going on. Okay? Going up here into Benton City, Washington. This is another 1.3 tremor here. This is over in western Washington. This is Morton, Washington. 7 miles northwest of Morton, Washington. Okay? This is a 1.9 tremor. 1.9 tremor. Usually they equate Morton, Washington to its location near Mount St. Helens. This is northwest of Mount St. Helens, and yet they don't have any earthquakes at St. Helens, Rainier, or over here just east of there at Mount Adams. At Mount Adams. Nothing at Mount Hood, nothing at Newberry, nothing at Sisters Volcano or anything. Nothing. Okay? Now I'm going to leave this because I want to talk to you about emergencies now here in the Cascadia region. With all these earthquakes that we've talked about in the Cascadia region, we have reason to be concerned about everyone's safety. We have very good reasons to be concerned about everyone's safety as a result of the Cascadia megathrust earthquake. What are you going to do? What are you going to do when this earthquake hits? Okay? The earthquake's going to hit out here along the Juan de Fuca Fault, or the Cascadia subduction zone fault here, just off the coast of Seattle. It's going to destroy everything. Vancouver Island, British Columbia, southwestern British Columbia, over here in Washington and Oregon, a 9.0, 10.0 magnitude earthquake, and then the subsequent tsunami that could have water as high as 150 feet deep, one after another after another. It's not just going to be one tsunami wave. It's going to be multiple, probably 30 or 40, 50, 60 tsunami waves, one after the other, wiping out the entire coastline of North America, Western Canada, and Alaska. Then that same tsunami wave is going to go west. Japan. It's going down south also along the western coast of California, down into northern Mexico, south over towards Hawaii, Indonesia, Guam, Australia, Tonga and Fiji, and probably by the time it gets there it'll be less, but it could hit New Zealand as well. Huge tsunami wave, guys. It's happened before. What is everybody going to do? Demon Cat, my dear friend, says we hope minimal damage. Stay safe. I agree. We hope for minimal damage. But folks, nobody has been alive 328 years ago when the last quake hit. We do not know how damaging it can be. We have good reason to believe it will be damaging to the point of almost no return. What I want to talk about with my remaining time now for the next hour, I want to talk about the coming Cascadia megathrust earthquake, our risks, and choosing routes to safer areas. I'm sorry. Didn't mean to cough in your ears, guys, for those of you that are using headphones. Excuse me, I'm going to get a drink of water. There are absolutely no safe routes or safe zones following the upcoming Cascadia megathrust earthquake. There are only safer routes and safer zones. Some associated risks can be avoided in their entirety. Others risks can be reduced. My intent tonight is to inform everyone of the associated risks so that you might act to reduce your risk exposure following the Cascadia megathrust earthquake, according to your own best decisions. I can't make the decisions for you. That's utterly impossible. But I can help give you information to help make your best decisions even more plausible. Few people even recognize the reactivation of volcanoes. and volcanic fields that has been going on for several years now. Or the tree kill evidence that says this has been ongoing since 2005. The failure to recognize the reactivation of volcanoes, also includes lesser known smaller volcanoes and volcano fields, all the way from Mexico to mid-British Columbia, and all areas between, as well as in Alaska. That's why I talked about Alaska tonight. The evidence says that the Cascadia megathrust earthquake will be as much as a massive volcanic event as it is an earthquake and a tsunami event. May I suggest you read what is going on? We put out a white paper a number of years ago. Those of you that have access to that white paper, feel free to offer it to other people. I even have a copy of that white paper. Now, when we talk about tsunamis, how high is high enough? Quite frankly, there are too many variables to know for certain. Higher is better. My estimation is this, and so is Terry Rempel's. My estimation is 600 feet to allow for the worst potentials. Getting up over 600 feet above sea level to account for the worst potentials. There is no one that absolutely knows how large this Cascadia megathrust earthquake is going to be, nor the tsunami that it causes. There are superquakes in the Cascadia megathrust history that come at earthquake cluster ends. Earthquake cluster ends. This has occurred in 2 out of 3 clusters in the last 10,000 years. The evidence says, as we are likely at a cluster end this time, that things are just getting started. As we are at a cluster end at this point in time. Okay? What do you think might happen? What does everybody think might happen? Let's talk about volcanic risks. Now, I have a lot of information here, but I'm going to highlight it because we are of a limited time frame here. First off, I'm going to give you my summary of the events in regards to the volcanic risks. Volcanic ash contains altered silicates and other minerals in various sizes. Toxins may also be included in the ash, such as sulfur, strong acids, and we've talked about fluoride. These particles, commonly coated with volcanic acids, are quite irritating to the eyes and to the skin and the lungs. If rain is involved, the acid is a direct skin irritant and risk in the eyes increases. One should always use the best respiratory protection they have available and not expose themselves to more volcanic ash than is absolutely necessary. Do not expose yourselves to any more volcanic ash than absolutely necessary. Wear long sleeve clothes and long pants. Make sure your skin is covered. If you have to be out in the ash, do so only for minimal times, and make sure you rid yourself of these clothes and wash off immediately, thoroughly, to get all of the ash out of your hair, off your face, and in your body. Get rid of it. Now, when we talk about silicas, there is a term that's called silicosis. This is not a concern regarding volcanic ash, according to recent medical research. Presumably, this is because the ash is such a strong irritant that it quickly is expelled by coughing. I can find no medical studies that conclude that freshly erupted volcanic ash will cause silicosis. I leave you with one study as a reference. Gunnar Gudmundsson, a recent study. This is a Swede, Gunnar Gudmundsson, Gudmundsson. Respiratory exacerbation of any pre-existing lung conditions is the most common issue here. Respiratory exacerbation of any pre-existing lung condition is going to be the most causative issue. Okay? Hydrogen halides are strong acids that are emitted from volcanoes, and these often coat the ash. This makes the volcanic ash a very strong respiratory irritant. Inescapable environment with heavy ashfall. Without respiratory protection, respiratory failure could result. This is considered rare, as there are few accounts of large populations being entrapped in heavy ashfall environments for a significant time period. It can happen, but there are very few accounts of populations being entrapped in that heavy ash. Volcanic ash is an eye irritant due to not only the particulate matter, but also the acids that commonly coat it. Prolonged exposure will lead to corneal abrasion from those tiny ash particles getting into your cornea. Then conjunctivitis, and then enough acidic ash exposure could cause irreparable damage to your eyes. That's why we have suggested wearing goggles to protect your eyes. Contact lenses should not be worn while exposed to the ash. I repeat, contact lenses should not be worn when exposed to the ash. Now, as for the weight of the ash, as it is pulverized rock, it is heavy. 1 square yard 4 inches thick weighs between 120 and 200 pounds. 1 square yard 4 inches thick weighs between 120 pounds and 200 pounds. And double that if it is wet. When it is wet, it turns to concrete. Then you're in real trouble. That's when roofs collapse, and even homes could collapse depending on the amount of ash on top of your home. This could cause collapsed roofs. Wet ash is also electrically conductive. It could short-circuit transformers. Power loss is common. Ash clouds. We've seen this in previous volcanic eruptions around the globe. Ash clouds disrupt airwave communication and air travel due to associated electrical discharge within the ash clouds themselves. The Cascadia mega thrust earthquake will also have disabled communication infrastructure because of the shaking and the damage to the radio transmitters and receivers. Ash clouds, as we have talked about before, will penetrate air filtering systems in not just cars, but air conditioners and heaters in the area, or any area where the ash is falling, which could be thousands of miles to the north, east, west, and south. Extensive ash. Volcanism from multiple stratovolcano eruptions would produce extensive ash. We're talking about possibly from Mount Baker, Glacier Peak, Mount Rainier, Mount St. Helens, Mount Hood, and every volcano large and small south of that. Any number of volcanoes could possibly erupt in connection with one other volcano or two other volcanoes. As one person said that was offshore when the last Cascadia megathrust earthquake happened, he was a mariner out to sea, and his logbook said that he thought either Mount Rainier or Glacier Peak was erupting. It could have been more than that. Water contamination. In 1912, ash from Katmai Volcano in Alaska covered the fresh surface of water and water sources with ash. The lakes and water sources were contaminated with ash fallen on top of the water. Acidity in the ash can make the water unfit for consumption, even if it is filtered. The pH adjustment would also be required to adjust the pH before you can even drink it. But fluoride is also a volcanic ash byproduct, and it is toxic in sufficient quantities. Contaminated water is a very real concern regarding extensive ash output. This could last for years. Ash is also toxic to plants for years. Increased soil acidity, fluoride poisoning, leaf coverage blocking photosynthesis and making the plant die, and plant respiration with the ash covering the leaves are just some of the causes of the death of the plants, and possibly the death of the fruits of the plants. Extensive ash can create biological wastelands for years to come. Grazing risks. Animals. Ingestion of significant ash through grazing results in high mortality rate for all grazing animals. And life of the animals, because they can be coated in ash. Ash gets down in their hair or their skin and then causes irretrievable, irreversible damage. They could breathe it. Ash getting in the eyes of horses, goats, dogs, cats, sheep. It can be deadly. Small animals worse. Blindness. Blindness described by Alaskan residents in older documentation. Dogs were blinded by both ash, acid rain, and ash causes. Wild animals were also found blinded as well. Fish kills. Ash causes short-term fish kill. Delicate gill structures do not tolerate ash well. Ash also depletes the algae that the fish feed on, part of the food chain. Shellfish are equally affected. Volcanic gases, carbon dioxide and sulfuric dioxide. We talked about this during the eruptions of the volcanoes in Hawaii. Water is steam. Okay? Water is steam. When the molten lava hits the water, it produces steam. It also produces what they call Pele's hair. When the molten lava comes in contact with that cooler water, it literally explodes. That explosion can cause those little tiny fibers to come off that lava. Those tiny fibers are glass fibers. That's why they call it Pele's hair. That can get on your skin and cut your skin. It could lacerate your eyes. It could lacerate your skin. It could get in your in your mouth, down in your trachea, and into your lungs, and cause probably irreversible damage. Okay? Strong acids called hydrochloric halides that we talked about a little bit ago. 3 kinds of strong acids. Fluorine and hydrofluorine, some volcanoes producing higher levels of those chemicals as well. Lower concentration of gases may include hydrogen sulfide, carbon monoxide, carbon dioxide, carbon disulfide, carbon sulfide, hydrogen, hydrogen sulfide, chlorine, boron, methane, mercury vapor. Those are not going to be good either. You need to prepare yourselves and your animals. Okay? Don't let your animals get down into a gully, for example, where these gases that are heavier than air might accumulate closer to the ground where these animals are, and they'll die. Okay? Mercury vapor especially. Organic compounds, yes, even gold. Strangely enough, even gold can result from a volcanic eruption. Let's talk about pyroclastic flows and lahars. We talked about this a long time ago. I'm talking about it now. Pyroclastic flows are associated with stratovolcano eruptions. They are made up of superheated gases as hot as 1300 degrees Fahrenheit and contain not only ash, but large chunks of rock and boulders. They travel at an average speed of 62 miles per hour, but they can reach speeds of 430 miles per hour as well. 62 to 430 miles per hour. Steep slopes and eruption columns and the collapse of the rim of the volcano are 2 factors related to the speed of a pyroclastic flow. They can also create an air cushion factor, an air cushion underneath them, according to recent studies. That means the flow can increase in speed a lot faster, and resistance would be very low with that air cushion underneath it. These are incredibly destructive. These could reach out to 20 miles away. 20 miles away, and more in some cases. They can also combine with melting snow and ice and become a lahar, which can be up to 500 feet in depth. 500 feet in depth and travel over 30 miles away. This is very common. Lahars can be formed alone from volcanic heating of snow. We talked about that a couple years ago when we had snow and ice on the side of Mount Rainier. And I showed you a video of that snow and ice coming down off the top of Mount Rainier. Coming down the top of Mount Rainier, taking rock and sand, all kinds of debris, trees, tree limbs, all kinds of nasties, all down the side of Mount Rainier. It caused a lahar that the authorities denied happened. It actually destroyed a road and a lot of property. But authorities denied it happened until I showed the video. Then all of a sudden hell broke loose. Yes, it can happen. Mount Baker years ago had an explosive eruption about 6,600 years ago, and another occurred in 1843. There's no record of a pyroclastic flow, however, not off Mount Baker. It has produced very large lahars that have stretched into Puget Sound. Mount Baker, a lahar that stretched into Puget Sound. One lahar was 330 feet deep. 330 feet deep near Mount Baker, and 25 feet deep 30 miles away. Now get this. There are approximately 100,000 Washington State residents living directly atop Old Mount Baker Lahars. On top of Mount Baker Lahars. Most people don't even realize that. Okay? It's incredible, guys. This is incredible. Animals and Humans in Disaster over in Arizona is in the chat tonight. The app's pet owner Powership survey says of 2022, U.S. homes 70% have at least one pet. We are successful in disaster preparedness in Arizona because we are disaster prep for beloved animals and pets. I hope all of you will consider your animals and pets. Don't forget them. Okay? Don Patoka, one of my mods here, a very dear friend. Do you realize or understand the psychology of desperate people or mobs? Keeping your head on a swivel, exercising logic over emotion, and ponder before action. These are good words that we all need to remember. I just told you about Mount Baker. How about Glacier Peak 40 miles to the south? Less is known about Glacier Peak. It's erupted at least 6 times in the last 14,000 years. 2 of those eruptions were 5 times larger than Mount St. Helens in 1980. These past eruptions produced tephra deposits from ash, pyroclastic flows and lahars that reach Puget Sound, homes built on top of lahars from Glacier Peak. How about Mount Rainier to the south of that? There is geologic evidence of 30 to 40 pyroclastic flows from Mount Rainier alone over the past 5,600 years. Mount Rainier holds more than 1 cubic mile of ice. 1 cubic mile of ice. These often join to form lahars. They've been recorded to travel a distance of 60 miles and 100, 500, and 1,000 years. Very large lahars reach the Puget Sound every 500 to 1,000 years. They've been recorded to travel a distance of 60 miles and have been as deep as 484 feet. Those lahars have been as deep as 484 feet deep. During the Cascadia megathrust earthquake, Mount Rainier is likely to produce a massive pyroclastic flow and or a lahar again. Meanwhile, over 200,000 Washington residents live directly on top of past lahars from Mount Rainier. 200,000 people. And those lahars are 300 feet deep. Let's talk about Mount Adams to the east of Mount St. Helens. Rarely does this volcano produce a pyroclastic flow. It does have a more frequent history of producing lahars, but only up to 8 miles distance. 8 miles distance. That might be nice to hear. That it's not going to be that dangerous from Mount Adams. Mount St. Helens is a different story. Mount St. Helens is well known to have at least erupted since 1980 and again in the early 2000s. Pyroclastic flows and lahars are both potentials for Mount St. Helens, but lahar is currently a lower risk as this volcano has less height now and less snow to melt as a result. Let's talk about Mount Hood. We've talked recently a lot about Mount Hood, erupting every 200 to 1500 years. Mount Hood is known to produce pyroclastic flows from lahars and dome collapses that normally travel no more than 8 miles. These commonly mix with melted snow and ice to form lahars. 100,000 years ago, a lahar was produced by Mount Hood that was 400 feet thick and stretched about 27 miles north. This changed the course of the Columbia River, and small lahars are even more common. Now, I'm not going to talk about each and every volcano. Mount Jefferson, Sisters Volcano, North Sisters, Middle Sister, and Broken Top are all large adjoining volcanoes that form the Three Sisters group. Mount Shasta is the most voluminous volcano in the Cascade Range. The USGS publications stated Mount Shasta is capable of producing pyroclastic flows 13 miles and lahars in excess of 30 miles in length. It last erupted in 1876, as recorded by explorer La Perouse from offshore, another mariner offshore. It has erupted every 250 years on average for the last 750 years, and at least once per 800 years over the previous 10,000. So we have to be concerned about Shasta. How about Lassen? Lassen erupted last in 1915. There are reports and images from the eruption that the phreatic blast reached 30,000 feet high. The phreatic blast reached 30,000 feet high. This is one of the better indicators of the potential of the Cascade volcanoes. Mount Lassen had at that point had not erupted for the previous 27,000 years. This was preceded by 180 major steam venting episodes, described as explosion in the 6+ months prior to the eruption. How many steam episodes have we already had for Mount Lassen? So Mount Lassen is a prime candidate for eruption, isn't it? Okay? For right now, that is going to complete my list of the volcanoes that have the highest threat of pyroclastic flows and eruptions and lahars here in the states of Washington, Oregon, and California. But that's not over, folks. There's a lot more. British Columbia, Canada has reactive volcanoes as well. They're all waking up. Alaska has many more volcanoes that are becoming more active as of late. Fortunately for Alaskan residents, the threat that they face would be related to pyroclastic flows and lahars, and it's going to be low threat due to the remoteness of the volcanoes in Alaska. Now, California is being monitored. All the volcanoes in California are being monitored. Okay? Every one of the volcanoes in California is showing reactivation. We talked about the Salton Sea lately, haven't we? the Salton Butte volcano, both south to the border and north to the Garlock Fault, has magma infill signatures from the Salton Butte volcano. From the Garlock Fault south to the border, magma infill signatures from the Salton Butte volcano. Now, since the most active seismic area is Bombay Beach, why do you think we've talked a lot about Bombay Beach? That is the most active area right now. Not just with tremors, not just with minor earthquakes. Full-blown earthquakes, 3.0 to 4.0, are hitting Bombay Beach at present. Today, that is on the eastern shore of the Salton Sea. It appears that the Salton Sea itself is a lake inside a caldera of the Salton Butte volcano. The Salton Sea is a lake within the caldera of the Salton Butte volcano. The filled caldera is going to cause a massive stratospheric eruption. Because there's water inside the rim of the volcano, it could cause a massive stratospheric eruption. That's not just there. How about Clear Lake volcano up in Northern California? How about Crater Lake in south central Oregon? Okay? And those are just a handful. There's a lot more than that. We've talked about the La Puente area itself, east of Los Angeles and west of Riverside. This is an apparent 11-mile wide caldera, and it has infill signatures that mirror the infill signatures at the Salton Butte volcano, at the Bombay Beach site. Except at La Puente, they're a little larger and more numerous. We've shown you that activity the other day. Based on this finding alone, I consider the La Puente caldera to pose a threat of eruption associated with the Cascadia megathrust eruption. The earthquake. Associated with the Cascadia megathrust earthquake. Okay? It has a great big caldera ridge formation, as well as a great big huge bowl-shaped depression and a center uprise area. The center uprise area is the plug of the volcano. Searles Valley has a high potential of major subsidence and lava extrusion. It's right in the middle of a bunch of volcanoes. Koza Volcanic Field to the north has a high potential of major subsidence and lava extrusion. Areas north of there are full of hot spots and small earthquakes in Nevada. Major subsidence risk. To the north there, we have Mammoth Volcano, don't we? North of there, we have the Mono and Inyo Volcanic Field. Mono Volcano is a great big lake with a great big huge island in the middle that's actually the plug of the volcano. Sutter Butte in California also has a potential to erupt in a small way. And it also has indications of a local lava flow. Mount Lassen has had recent earthquakes, a lot of them. We talked about them tonight. We talked about the steam signatures as well. Mount Lassen steaming. The associated seismological sites are poor because USGS does not want to be honest with us. USGS does not give us the best information about what's happening at Mount Lassen. And yet it is a consistent danger to anyone and any people that live around it. This is an area of approximately 90 square miles. We use Google Earth to fact check the dates of the beginning of the tree kill associated with Mount Lassen. And we found the tree kill began in 2013. Why do we have tree kill? From gases emitted by the magma inside the volcano. That's why we have tree kill. Magma infill into the area. Magma infill causes an uprise of gases that kill tree root systems. This is established science. Mammoth volcano. We're seeing 3.0 to 4.0 earthquakes and significant infill activity, plus hotspots. This may constitute a stratospheric eruption potential. Then we have a supervolcano to the east with the same potential. Mount Shasta has potential for stratospheric eruptions. Satellite imagery has shown major venting episodes at Mount Shasta. We've reported on this. Whaleback north of Shasta has tree kill areas. Back-checking imagery dating back to 2009. Gases from Mount Shasta. Tree kill since 2009. Long Valley Caldera, the supervolcano. All I can say is I sincerely hope not, for it is a massive, massive volcano. Most of the Long Valley Caldera activity has been at Mammoth Mountain, which is associated with Long Valley. Lake Tahoe has also associated volcanic features. This area has been quite active with small quakes and tremors. There are all kinds of unnamed cinder cones and craters that we're not even mentioning tonight. Most of those cones and craters don't even have names. In Oregon, all of the monitored volcanic areas in Oregon show volcanic reactivation signatures. Folks, what I am telling you is you need to be aware around you. Everyone here from the Mexican border north on the west coast, you could be affected by a Cascade megathrust earthquake and subsequent volcanic eruptions. Every one of these volcanoes from the Mexican border north, and I'm not just talking about the Mexican-American border, I'm talking even south of the border at Cerro Prieto Volcano. Cerro Prieto Volcano can erupt. It's not showing too much tendency to tremors and earthquakes, but it has had some. Okay? I talked to you earlier about Newberry Volcano. That's also lake filled. A stratospheric eruption could result. Newberry is connected to Crater Lake volcanic field, and it's littered with cinder cones and lava expulsions from the buttes and the cones and small calderas, some with lakes, which could cause a stratospheric eruption. Anytime we have water at the tops of these volcanic fields could result in a stratospheric eruption with the hot magma hitting the water. Not a good mix. Mount Washington is large enough to be mentioned, just north of Sisters, between active volcanoes. It's surrounded by recent tree kill as well. The belt averages approximately 1.7 miles in width, and diameter of the crescent is about 5 miles. Tree kill onset began in 2012. Okay? Every one of these volcanoes, craters, and cones could erupt. We've talked about hotspots. We've talked about earthquakes at the volcanoes. We have talked about steam signatures. We've shown you steam coming from these volcanoes. Every one of them could result in an eruption. What are we going to do about it? Okay? What also do we need to know about these volcanoes and the Cascadia megathrust earthquake? Have you thought about nuclear power plants? San Onofre in North San Diego County is decommissioned. It's just by the coast. It's on the beach. It's decommissioned, but it's still hot. Should California be involved with the Cascadia megathrust earthquake, which it will, this could pose a very likely risk to the population north into San Clemente, east into Camp Pendleton, Oceanside, south into Encinitas, and possibly further into San Diego, and points east as well. Every dam up and down the coast in the western part of the country, every dam in Washington, Oregon, and California, and even points east, Idaho, Utah, Montana, Wyoming, Colorado, New Mexico, and even in Arizona could be affected. Every state listed here has dams across major and minor rivers. These dams are at great risk of failure during a Cascadia megathrust earthquake. Learn about the dams in your area in relation to immediate threats, as well as dams along your route to a chosen safe location. You need to be aware of it. We've talked about hotspot imagery. We've talked about it before. We've shown you hotspot imagery in the past years. Seismic activity related to subsurface magma movement. Tree kill evidence all the way over to Montana and Wyoming. Tree kill evidence. Yellowstone. Terry and I spent several hours examining tree kill evidence in Yellowstone, Washington, and Oregon, and all up and down the entire western United States. Tree kill evidence caused by magma beneath the surface releasing gases, getting into the root systems and killing trees. The evidence says the impact of this would be the highest in California, both east and west, except the northwestern area and eastern Washington, and Oregon shows itself as well. High risk of significant subsidence, meaning the ground being lowered after the volcanic eruption. The magma chambers releasing the magma, and the ground moving downwards. There is a lower risk of significant ground subsidence in western Washington, western Oregon, and particularly southwestern Oregon. Prepare your escape routes, east and south, desert environments except for northeastern Washington state. All of the areas east of the Cascade Range, the Sierra Nevadas and central southern California mountain ranges are all deserts. This presents a great obstacle on its own. There are hundreds of miles of desert to cross east of the Cascades in Oregon or Northern California. You should consider the following if considering going east or south. Are the roads still intact? Do you have enough fuel to make it? Do you have spare air filters on your vehicle? If not, get them. Are the volcanoes erupting? Let me get another little bit of water. If the volcanoes are erupting, how much ash is being produced? Are multiple volcanic beds expelling lava, as they have done recurrently over tens of thousands of years? Is there enough subsidence that the land inland sea area has returned to the east of the mountains? Is there enough subsidence that the inland sea has returned to the east of the mountain areas, meaning water in the areas that used to be dry before all this started? The safest western U.S. areas for people located in the Cascade Range and west are in northwestern California and south of Medford, Oregon. This is according to seismographic evidence that we all compiled, and elevation assessments. Remember elevation, that's going to be critical. Plus 7 other layers of evidence. There is an associate temporary safer area map that might assist you further in the event of volcanic eruptions. People located east of the Cascades should head north to the Idaho Panhandle and the Canadian border. Let me tell you again. In the event of major eruptions, people located east of the Cascades should head north to the Idaho Panhandle and the Canadian border. The Oregon area is relatively safe, is bordered by Highway 199 to the west and Highway I-5 to the east. The east entry point is Cave Junction. The north entry is through Grants Pass on Highway 238. That's also the west entry point. By either taking the West Pine exit from I-5 in Central Point and connecting to Hanley Road, Highway 238, or coming up from the south on I-5, you take the Fern Valley Road exit off of I-5. Turn north on South Pacific Highway, then take the South Stage Road exit that connects to Highway 238. We expect this will be added to the defining of the safe zones. All the routes into this zone likely have advertising for the Oregon caves via road signage. If you have doubts, go back and go through this video again and make sure you've heard this correctly. Okay? In my opinion, the way to a safer area for most of California is along the western edge of the Sierra Nevadas. We have studied every seismogram and volcanic risk, including tsunami damage potentials, to give you this advice. And it is just that, advice. I can't know any time ahead of this Cascade megathrust earthquake event how much area will be affected with certainty. I don't know that. I don't have a crystal ball. You have to do your own work to determine that. That is why we have spent very many hours, a lot of time, to present you with the work that we've done, to define an area that should be safe after the Cascadia megathrust earthquake. How you prepare for this is entirely your choice. But keep in mind that the pioneers required a specific list of necessities to make a long journey and start over. They planned, The pioneers planned and they prepared. It is our suggestion to you. It is in your best interest to follow these lessons well. Plan and prepare. How many times have I said that this last year? Plan and prepare. I talk about this almost every day. These are lessons that we can learn from our pioneer ancestors. There is so much evidence that comes from all of this. There is too much evidence of what comes for you to face this unprepared. We've talked about being unprepared. Don't do it. You need to plan and you need to be prepared. Now, both Terry Rempel and I sincerely pray that you're going to see the truth of all of this. It's in your best interest and the interest of those of your family members as well. I hope and pray that you will consider the things that we've talked about. Sincerely think about what we've talked about so that you can prepare. That is in your best interest. Does anybody have any questions? I know I've already been at this now over or just about 2 hours. Does anybody have any questions? I want to make sure I'm going to be able to answer your questions before we say goodnight. Awaken says, yes, everyone needs meds, especially with a chronic problem. Okay? If someone has low sugar, you can help him by feeding him a little bit of sugar water to help him with his blood sugar problems. If he has diabetes, don't feed him sugar. Okay? Feed him something else that will raise his protein levels up. Okay? Crate says, great information tonight. Thank you, Ron. I'm very thankful for each one of you. We have 111 thumbs up, 112 now. I appreciate all of that. On your way out, please give us a thumbs up if you think this information has been poignant and worth your time. Please share this information far and wide. That's why we put this together for you. That's why Terry and I spent so much time on this. Yes, Terry wrote the original information. I have added to it. Please, everybody, think about this. This is vitally important for your safety. It really is. I hope and pray to God that God will bless you, that God will keep your mind in tune with His, that your minds will be clear, that you'll be able to function without exacerbation of your anxieties, that you will not over-exaggerate your abilities, that you'll keep in mind the dangers associated with that, and the dangers associated with what's going to happen. And it's not just everything I've talked about tonight. There's politics involved as well. Keep your head on a swivel. Keep your head on a swivel, guys. Now, folks, I'm serious about this. I want you to sincerely look at this and ponder the information we gave you and save it. Take notes, go back and take notes if you haven't already, and save the information. Write your plans. Write your plans and take your necessary activities further to prepare a safe zone for you and your families. I prayed a lot about this tonight. I prayed a lot about it. I'm trying to save lives here. My buddy Brian Clark is here, and I want to thank him for being here. Brian and I have known each other for a very, very long time. I love the man. I love the man. He and his family are very, very dear to me. I used to work for his father. I looked up to his father as a man that was a second father to me. Brian and his brothers and sisters were very important to me. I loved each and every one of them. All of you are very important as well. That's why I put this piece together for you tonight. Folks, we are not going to be on air tonight or tomorrow. If something else happens that's very important or that might become dangerous, we will come back on the air to report it to you as soon as the information comes available again. But folks, we take Saturdays off, or at least try to. Yes, we've come on the air on Saturdays before, and we will again. But we try to take Saturdays off. We come back here on Sunday mornings, sometime after 12 noon, with a program that we like to call Sunday School. Come follow me, the Savior said. We're going to continue to talk about the life of the Savior and his mission. We're going to talk about the apostles and what they said and the importance of the mission of the Savior. I love you. Please share this information and please join us on Sunday, probably just after 12 noon. I've been having a lot of technical difficulties because of the internet lately. A lot. Possibly by the platform. I hope it's not just them. But folks, please join us on Sunday. It will be very important to you. Folks, I'm not going to show you the scripture tonight. I want you to go look for it. Philippians 1, 1 through 4. Philippians 1, 1 through 4. I love you, folks. I love you. Nancy Wolfer is asking, Ron, will this affect Colorado? Most certainly will. Ash will blow east. So yes, it will. And people leaving Washington, Oregon, and possibly even California, they're going to be headed east. Idaho, Oregon, Utah, and Colorado, Washington and Wyoming. The problem with that is there's going to be ash being blown east. And with the Cascadia megathrust earthquake, everybody across the entire continent, across the entire American continent, North American continent, north to south, east to west, are going to feel the 9.0, 10.0 magnitude earthquake. All the way to the East Coast. You're going to feel some part of the shaking. Fact. Ash from the volcanoes, you're going to see it. You're going to get it. Sherry Belfast says, I came in late here to rerun the program. Please do. Please take notes. If you come in here late, please take notes of everything we've talked about. This is very, very, very important. Michael McKinney says, will that ash make it to Southern California? Michael, you're going to have volcanoes in Southern California. We talked about La Puente, Caldera. That's a volcano just west of Riverside, south of LA, south and east of LA. You've also got to contend with the Salt Butte volcano, Mammoth volcano, Koza volcanic field. And you're also going to have to contend with that great big huge super volcano that's connected to Mammoth. Okay? Oh yeah. The one whom Jesus loves says La Puente. No, it's Puente. Puente. La Puente. L-A, capital L-A, capital Puente. La Puente. Okay? It's a volcano. And I showed you evidence of the earthquakes that are hitting there, caused by magma underneath it. Okay? Consider that. I hope you have a great night. Like I said, go and read Philippians 1 through 4, because that is how I feel about each and every one of you. I love you. I do. You are my family. Folks, God be with you this day and always. God be with you and God bless you. God be with you until we meet again. Have a good night, folks, and thank you all for being here. I want to thank my mods as well. You mods are the bread and butter of this show. You get us through everything. God bless you all. Like I said, give us a thumbs up, guys. Leave comments in the comments below this video. If you want to contribute to what we do here, you can go to our PayPal and also our Venmo locations that are mentioned in the top portion of our program description tonight. Okay? You can go there and take a look at that. If you have questions, I will consider questions on Monday evening. Write down your questions and bring them to us Monday evening. Until then, guys, I hope you have a good night. Juanito is here. Juanito is usually one of the first people on this program, and I appreciate him very much. God bless you, brother. I appreciate you very much. Demon Catman, I love you, brother. He's in East England, and he makes it here almost every day without fail. And he's sometimes one of the first ones in here. That's cool. That's really cool. Demon Catman, thank you. He says, bless you, Ron. No, bless you all. My friend Rob. I talk to all of you guys almost all the time. I love you all. God be bless you. God be with you till we meet again. Have a good night, folks. I love you very much. We'll see you on the other side. See you Sunday. Good night. Have a great weekend. See you later, guys.